So today we're going to be looking at a couple of AP questions that relate to the topics that we've been working on so far. We can't look at a full AP question yet because we don't quite have enough information. So I've taken a couple of pieces of AP questions that we're going to take a look at that have been given on AP exams for the last couple of years. The first one is that the function f is defined by the function f of x equals the square root of 25 minus x squared, as long as x is between -5 and 5 inclusive. And then we're going to let g be the function that's defined by the piecewise function g of x equals f of x if x is between -5 and 3, inclusive at -5 and inclusive at -3. And then we're going to look at, is g continuous at x equals 3? Now note this last part down here. They told us to use the definition of continuity to explain our answer. That means that we're going to have to show that all three of the requirements for something to be continuous hold true at this particular point. The first requirement was that we had to make sure that the function was defined at the point that I'm interested in. So the first thing that I'm going to do is I'm going to say g of 3 is going to be equal to, now at 3 we're using the top function, so that's going to be equal to f of 3, which if I go back here, that's going to be equal to the square root of 25 minus 3 squared, which is the square root of 16 the square root of 16, which is equal to 4. So the function does exist at x equals 3, and so I'm good with the first part. The first part is verified. Second requirement was that I have to look at the limit from as x approaches 3 from the left and make sure that that equals the limit as x approaches 3 from the right. So we're going to look at those two things here. These two functions, the f of x function that we're using on the top and 7 minus x, are both continuous as long as they're defined. So as long as we're in these intervals, they're continuous functions. So I'm going to be able to do this pretty easily here. I'm going to look at the limit as x approaches 3 from the left of g of x, which is going to be equal to the limit, since we're looking to the left of g of x, that's in this region right here, it's in this interval, so I'm going to be using the f of x function, so that's the limit as x approaches 3 from the left of f of x, and this one I can just plug in 3 into the function there, and I get the same thing that I got up here. It's going to be the square root of 25 minus 3 squared, which again is the square root of 16, which is equal to 4. So I'm okay with that. Then the next thing that I'm going to look at is the limit as x approaches 3 from the right-hand side of g of x. For this one, since I'm to the right of g of x, I'm going to plug in 3 into the second equation here. So this is going to be the limit as x approaches 3 from the right of 7 minus x. And when I plug in 3 for that, I get 7 minus 3, which is equal to 4. And now I can see that the limit from the left is equal to the limit from the right. That was the second requirement. So I've got my first requirement here, that f of x, that g of 3 is defined. I've got that the limit from the left is equal to the limit from the right, so I can conclude here that the limit as x approaches 3 from the left of g of x is equal to the limit as x approaches 3 from the right of g of x, and that's also equal to g of 3. That was the last requirement, that the value of the function had to be equal to the value of the limit from the left and the limit from the right. Sure enough, that holds true here, so the function is continuous. I've got the three requirements here, so g is continuous, So g is continuous at x equals 3. Those were my three requirements. I had to show, once again, the value of the function existed, the limit from the left was equal to the limit from the right, and then we had to show that the value of the function was equal to the value of the limit, which happened in all three cases. I was able to satisfy all three things, and so now I can say that this function is continuous at x equals 3. Next, we're going to look at what happens if we start looking at an intermediate value problem from an AP exam.